Here's a tough question. When students first do algebra, they might have to encounter this type of problem, in which we're trying to figure out how long Amanda takes to complete a math problem on her own, if we are given how long Bob takes and how long it takes for both of them to do the math problem. Now, a lot of students like to think something like this. So Bob takes 10 minutes to do his problem. So this is for Bob. And then they're thinking, well, if that's how long he takes, if he's working with Amanda, his time probably decreases, right? Because if Amanda's working and Bob's working, then it's probably not going to take 10 minutes. It's probably take a little bit less. And we're trying to figure out how long it takes Amanda to do a problem. And we know that together they take 6 minutes. So they write something like this, right? So 10 minus maybe like Amanda equals 6. And then they get Amanda equals 4. Okay? But of course, this answer doesn't make any sense. How can Amanda complete a math problem faster than if she was working with Bob on a question? It makes no sense, right? Amanda must take longer than 6 minutes. And obviously this question is kind of maybe ambiguous, because in the real world, by the way, most times when two people work on a problem, it's just the faster person is going to do all the work. But in this case, let's assume they work at a constant rate. If this is true, and there's a hint, these are rates. So you can't actually do 6 minutes, 10 minutes, and then let's call it X minutes for Amanda, because these are actually not the units that are given in the problem. We're not given that it's 6 minutes. We're given that one problem takes 6 minutes. So it really should look like this, 1 over 6, where it's one problem is completed every 6 minutes. And so technically, if Amanda and Bob work together, we should be adding their rates. So if it takes Bob 10 minutes, his rate is like this, one problem every 10 minutes. So we get a fraction 1 over 10. We're trying to add Amanda. She does one problem in X minutes. And together, when we add those two fractions, we should get that it takes 6 minutes to do one problem. So our overall equation is 1/10 plus 1 over x is equal to 1 over 6. And that would make more sense because we're adding rates. And adding rates is perfectly fine. It's like if you're running at 20 miles per hour and then you run 5 miles per hour faster, you're going to run at 25 miles per hour, although you're pretty fast if you can run at that pace. But anyways, at that point, we can just get rid of all of this. We have our equation. Let's just go ahead and solve this equation. So 1 over 10 plus 1 over x equals 1 over 6. And just to review, 1 over 10 is Bob's rate. Amanda's rate is 1 over x. And the combined rate is 1 over 6. In order to do this, well, we can do 1 over x is equal to 1/6 minus 1/10. So we can subtract 1/10 on both sides to isolate the x. Here we don't want to do anything. We don't want to cheat. Let's just make a common denominator on the right side. So that would be 60. Do 10 over 60 minus 6 over 60. So we get 1 over x is equal to 4 over 60. If you simplify that fraction on the right side, you get 1 over 15, which implies that x equals 15. You can also cross multiply to get that step as well. If you really understood the concepts in this video, you should be able to do this problem.